Hello, everyone. Thanks for joining our webinar. We're going to give people a few minutes to sign in. So while you're waiting in the chat feature, if you could let us know where you're dialing in from, and then we're going to launch a poll. So please answer that as well and let us know which role you play at your company. We'll give people some extra time here.
We could launch the poll right now, yeah?
Yeah.
Oh,
Hey there. Oh, look at that.
There it is.
Very nice.
A little bit of everything.
And are people chatting in where they're from? Where are people calling in?
Got Chicago, Brazil.
Oh, we just went to Chicago in a couple of months ago, beginning of this summer. It's a great place to take kids to. Good food and good museums.
Ooh, a couple Ohios.
So if you are just joining, please tell us where you're dialing in from in the chat, and you should see a poll. Let us know what you do at your company.
It's good to see people representing Denver. That's where the majority of our team is located.
Got some West Coast representation on here. That's great too.
Definitely. Love for the West Coast.
Yes.
Got a lot of AppSec folks coming in, leadership, engineering, and DevOps. It's a great mix.
Yeah, it's gonna be great to see with all the engineering people, how they take some of the conversations that we have about, because I feel like at the end of the day, this is all about working together between the security and engineering teams. So I think it's good to hear it on both sides.
Okay, give it another minute or so, and then I'll just give some quick housekeeping, and then we'll dive into it.
Great.
All right. Well, let's get started. Thanks everyone for joining our webinar on discovering your attack surface in 15 minutes with API discovery from StackHawk. This webinar will be recorded and shared in the next day or so. And additionally, for those of you that stay till the end, you will be entered to win a $100 gift card to Grubhub. So lunch on StackHawk or dinner, whatever you fancy. So with that, I'm going to pass it over to April to get us started.
All right. 1 second. Here we go.
Nice.
All right.
Back to you, Alexa.
All right. Well, on that note, I'm very excited, and I'm very excited to introduce our speakers for today's conversation. We've got Scott Gerlach, our CSO, and StackHawk co-founder, Dan Hopkins, VP of Engineering, and April Conger, Senior Solutions Architect. With that, Dan, take it away.
Yeah, thanks so much, Alexa. Great to be here. Great to be talking to everyone, and such a good topic. I like that kickoff movie. I think that's really captures some of the drama around this feature. But let's kick off. We're going to talk a little bit here about what StackHawk does, and then we'll get into some of the details of this new feature. StackHawk was founded in 2019 by Scott Gerlach, who's on this phone with us, our CSO, Joni Clippard, who's our CEO, and Casey Berg, who's our chief architect. And really the biggest thing, we've been trying to solve for the last 5 years has been addressing the gap in security tools that were focused on, they typically focus on finding vulnerabilities, and we really wanted to make sure that we were focusing more on resolving the bugs early in the development cycle. And we thought that one of the biggest weaknesses in AppSec was DAST. And so we wanted to make that great again. I think there was a lot of people that were really downtrodden on DAST, and we wanted to bring that back and make it into a gold standard. And we wanted to embrace shift left. We wanted to bring these tools earlier in the dev cycle and really make it sure there was a trust gap between the security and engineering team. So we've been working with companies, and I think the biggest thing that we found is that the testing portion is not easy to get started, but it's certainly something that is tractable, that teams can get their head around. But really understanding their APIs that they have that they need to be getting under test is something that we hear from customers time and time again that they're having problems with. So we're going to talk about 3 different things today. One is, what is up with API sprawl? Why are there so many more APIs now versus, say, 15 years ago? Why is it difficult to find them? And, maybe if you talk to the engineering team, they say, hey, just ask us. We know exactly where the APIs are. But there is something lost in the communication between the 2 groups. And we have ideas about how to solve that. And then we're going to jump into a live demo, and then we'll do a recap. And I think we're giving away a Grubhub gift certificate. So make sure you stay all the way to the end. So why are APIs sprawling? April, tell us about this. What's happening?
Thanks, Dan. Let me tell you about that. So in the early days, application architecture was really simple. Like the whole problem of application security and application security testing was a lot smaller. And typically companies would have an architecture that looks a bit like this, where you've got users on the left interacting with a browser that's interacting with a set of application servers behind the corporate firewall. And those are running Ruby on Rails or PHP or maybe Java server pages, and just rendering HTML and delivering that to the browser. And, there wasn't a lot of API sprawl to deal with. So API discovery was not a problem that anybody was interested in. But that really didn't last very long. And now the modern architecture tends to look more like this, where you've got on the left, instead of just a browser, you've got a browser that's a runtime engine for JavaScript, or you've got mobile applications or some other client applications. And those applications are interacting with APIs in the background. And those APIs can be, quite numerous. A lot of times, single page applications are interacting with 3 or more APIs, often like really quite a few. And then behind those APIs, you probably have other APIs that are taking care of other calls. And even though they may not be publicly accessible in this diagram, we have a couple of behind the firewall, not publicly accessible gRPC applications, for instance. Those can become quite numerous in a lot of different architectures. And because, they're a great way partially to manage large application development teams and very rapid feature delivery across a lot of different domains at once. And so you can get quite a bit of microservice sprawl, for instance. And this is where a lot of this concern about hidden APIs that the AppSec team is unaware of, so this is where a lot of that concern comes from.
Sounds good. Well, let's talk a little bit more. I think that sets up the problem really well. And I was thinking back even through my transition being a developer the last time I was programming, doing, Ruby on Rails versus doing single page applications, and how much more difficult that made actually understanding what we were scaling again, or what we were working on. And I think that to follow up on what you're saying, April, what we're seeing from the research is that API usage overall is just up massively. This 71% of all web traffic is happening as either JavaScript or just pure API calls. And that APIs are really revolutionizing the way that software is built. And I think it's super interesting. It just makes it even more important to make sure that we understand all the APIs that we're deploying and make sure that we have them all properly tested. I think that, the next problem is understanding what APIs exist. And there are lots of different solutions that we're going to talk about here in a second. But I think the key thing is really, if I look at all of the APIs that are deployed into production, anything that's running on port 80 that is returning, say JSON or something like that, do I have a list of these somewhere? And do I know that they're all under test? And what we hear from customers, they have names for this, that that they're basically the scope that they don't understand, they call shadow APIs. That's things that are being developed, but that they don't necessarily aren't being tracked as part of inventory from the security team or something like that. And this is a little bit different than the shadow API's ugly sibling, the zombie API. That is an API that has been deprecated or removed, but it's still running in production. But this is all about information and kind of understanding between the AppSec team and the development team about what's going on. And this is more research, more quotations that we've gotten that talks really about how mitigating the API risk is just so difficult for some customers to handle. And it's important to realize that the scope of testing in an AppSec program is constantly changing, right? Like we look at customer data that they have, like the number of repositories that they have, or the number of APIs that they have. And even if you look at a pretty reasonably sized program, if you have a couple of hundred engineers to a couple thousand engineers, they'll very easily have multiple thousands of repositories, and new repositories are being created, almost every week at that scale. And so making sure that you're in a repository, almost inherently leads to new code running in production, which is new APIs most of the time. And I think that, making sure that you really understand how fast this is moving is just so critical to people.
Hey, Dan, can you go back one there real quick?
Yeah.
What do you think, as a engineering leader, what do you think is leading to this being a problem? Like, obviously software development is faster, but like, what are some of the things that development teams are doing that's making it hard for security teams to keep up? Especially considering, the ratio that we talk about all the time, which is 100 developers per one AppSec or maybe even security person, which I still think is screwed up. I think it's like 200 to 1. But what are some of the innovations in development that are leading to this?
I mean, it kind of goes back in my mind to like the original reason about why we adopted microservices. And that was, we really wanted teams to be able to move independently of each other and have control over their own destiny. Microservices were really facilitated by the DevOps movement, which took operations control out of an central operations team, moved it into development. And that really allowed the engineering team to move quickly, as you mentioned, which kind of meets with the pressures. But it also keeps the teams really isolated from each other. And by adopting microservices, you allow the teams to be really independent. But with that independence, they tend to communicate less even between development teams. There's a really famous memo that Jeff Bezos sent out that when he transitioned Amazon to basically the first microservices architecture, where he said, all teams will communicate through contracts, not through meetings. And so I think in that world, now all of a sudden you've got these really independent, isolated engineering teams that are moving independently of each other. And that means that the security team is also independent. So you've got all of these pieces that are changing and morphing. And the only way that they communicate with each other is by creating open API specs or SOAP WSDLs or something like that, where they actually send the contracts back and forth. And if that barely works inside of the engineering team, it does not communicate that information that's needed out to the security team very well.
So the security team was isolated from development before, but they used to get into a spot where they all kind of had to get together to release value or feature to customers. And now they can do it way more independently, which kind of isolates the security team even more.
Exactly.
Gotcha.
Exactly. So it's a good question for you now, Scott, is how are people actually discovering their APIs today?
Yeah, I think we have a poll for this. Would love to
there you
see.
go.
I would love to see what happens in here, and if anyone catches the fact that we quoted Donald Rumsfeld in this poll question. But there's a variety of different ways to do it, and I think we went to some extents in the previous days of DAST, in the DAST of yore, which Dan previously claimed earlier in the webinar was great, and therefore we were making it great again. I would say that is the EWIST phrase, but also again is a really large stretch. But the whole hope was, can I look at a web page and find all of the APIs that it talks to? And it's just impossible. Like, it doesn't work. If you talk to maybe the greatest web page crawler in the history of the world, Bing, they will tell you that if you want your web page crawled, don't do it in single page app. So having a security tool be able to be efficient and do it quickly is, again, impossible. So lots of different ways to think about APIs and how to discover them. I can't see the results of the poll, so that would be interesting to see. But we've got some ideas or some things that we've heard from customers on this slide. Dan, you want to walk through these a little bit?
Yeah, absolutely. I mean, we talk to customers about this problem, all the time. And I think basically we hear two different ways that people are generally doing it, and then one kind of shade of the same way. The first way, this is my favorite, Scott, can you believe it, is spreadsheets.
Hey, look, don't knock spreadsheets. Security folks will love spreadsheets. You got the columns and the rows and the cells, and it's infinitely manipulatable.
That's right. I mean, if it can't be expressed in tabular data, you got to really wonder if it even exists.
Yeah, unfortunately, one of the challenges with the spreadsheet is its point in time. Like, we've talked to more than one customer who's done this, like, go sit with engineering teams, which I recommend, but sit with engineering teams and spend a lot of time mapping out their code, the repository, what it does, what kind of data it handles, where it gets deployed, all that stuff. And as soon as you walk out of that meeting and go to the next team, that data is out of date. So that it's good information to have, and it can really help you prioritize and build a security program, but it gets out of date so fast, it's really hard to keep up with.
Mm-hmm. Yeah, I've seen that all the time. I think the internal developer dashboards, they're starting to become popular. I think that Spotify has shipped one. And I think there's a couple commercial offerings. I think they kind of fall into the same problems that spreadsheets do. Maybe they're a little bit better if they have more automation. If I have a giant pile of money and I spend it on production monitoring systems, won't that help me figure out this problem?
maybe. So this is probably my favorite subject that really kind of ticks me off. This whole idea that you can deploy a monitoring system into a cloud environment and therefore discover all of your APIs is just so ripe with farce. It's ridiculous. Like the idea that you can deploy an agent or a reverse proxy into an environment and therefore discover all of your APIs, there's exactly one way that that works correctly, and it is decrypt all your traffic, have it go through one single point of entry, and send it to a third party. That's like the trifecta of breaking all of the security rules for customer data protection. Like having a single point of failure, decrypting all the traffic, and sending it somewhere else. That's like, I am super uncomfortable with that. I don't know how everybody else feels, but what they're really saying to you is, if you know where you've deployed your APIs, you can deploy our tool and we can discover them. That's not discovery. That's, I know where they are. Now some of the things that come out of that are cool are, can I monitor for alerts? Can I see bad traffic happening? Those kinds of things. But again, if you don't know where the APIs are deployed, you're not going to get that information. And that's what makes API discovery super hard, especially in cloud environments where people have the ability and need, and businesses want the ability for development teams to deliver value to their customers super quickly. The idea that you already know where all of these things are deployed and therefore are now discovering them, it kind of makes my head spin a little bit.
Yeah, I couldn't agree more. So let's talk a little bit about what StackHawk is doing to solve this problem. I think, in our opinion, the source of truth is the code that everyone wrote. That's where the routes are actually defined. That's why, sometimes we talk about this feature, we talk about it with engineering teams, and they say, what do you mean? What do you mean you don't know where the APIs are? They're right here. And they like point to their code repository. And then they assume that you either understand how they've built the API, or they assume that you just, kind of magically understand how things are deployed to production. But StackHawk is taking the approach that we look at your code and we can figure out what's going on. And we think that by doing this, we really start to cover the entire life cycle of your APIs. So we can help you discover where they're developed. Then we can connect that to security and API testing. And then we can give you oversight into how your attack surface is changing over time. And we hear, all of this overall is encapsulated by a lot of the CISOs that we talked to, and actually a lot of the poll results. So the first question we had was, what keeps you up at night about your API AppSec, your API attack surface, or your app API program, or something to that effect? And the number one response was that the unknown unknowns, right? The things that you don't even know about. Is that what keeps you up at night, Scott?
Absolutely. That and my smoke detectors in my house, those are also keeping me up at night recently. So
yes, you should change the batteries.
I think the priority right now for me is a little screwed up. But unknown is really a big issue. Like, as a CISO, and if we've got CISOs out here, you can chime in the chat and +1 me. To build an effective cybersecurity program, you have to know what you have, period. Like, you have to know how the company makes money and why customers value what the company produces. And then you have to know what assets you have. And in application security and API security, you have to know what that attack surface looks like. And it doesn't necessarily matter if it's out on the internet attack surface or it's internal only attack surface. All of that stuff is attack surface. And if you don't know, it's really hard to build a program and go advocate and justify spend and investment into, and that an investment is money and people and time. I guess that's all money if you really talk about it. But that investment you have to advocate for with the executive leadership team and probably the board. And it's part of the board's responsibility too, to understand this and invest correctly. If you don't know what you have, you can't advocate well for a spend in a security program. That's period, point blank. So discovering what your attack surface looks like is super important. Then being able to invest in technology and process change that helps you effectively run that security program, and then having oversight into how that's going. Those are the really the key pillars of building and scaling an AppSec program inside of an organization. Because if you're missing one of those kind of 3 pillars, it's like a 3-legged stool. It's gonna fall down somewhere, because either you're not testing all the things, your testing can't keep up, or you have no idea how that program is going. So having those 3 pillars, the part of the AppSec program, is super, super hard to do, especially at scale, right? So Dan, you just said, when we ask devs, how do they do discovery on their API? They take kind of a developer focused sight into it and go, yeah, it's just right here in the code. And that's easy for them on their code. Now, if you took that across all of the teams and all of the repositories, they would run into the same problem that the security team does and go, this is a pretty big problem. I kind of don't have time to go through all of this code and figure all of it out. I know what I know, but I don't know the other stuff. So it's not only a security problem, it's also an engineering problem a little bit as well.
Yep, 100%. Yeah, when you have 10,000 code repositories, understanding all of them is going to take a lot of time. Well, April, why don't you show kind of what we're talking about here for solving this problem?
Sounds good. Let me pull up my screen, and I've got a fresh trial organization set up in StackHawk's. So this is what it looks like when you sign up for a free trial, or you've just signed up as a customer and you come into our platform. You will see this page, and it offers a lot of different ways that you can get started with StackHawk. And our newest, and we think one of the most important ways to get started, is to start securing your attack surface with our attack surface discovery. So I will show that flow, and actually you can get the same view, starting from here in our attack surface section. So I'll say I'm going to connect to a test organization in GitHub and show how this works, but know that you can also connect to Azure repos right now. You can connect to multiple organizations, and we've got Bitbucket lined up to be the next one available. And so you can have a mix of many different orgs across your company, or many different repo organizations. So let me get this started. I'm going to connect to my GitHub account. And here I've got a number of test organizations. I'm going to connect to this one for my company, Strike Plumage. And I'm going to just give it access to all of my repos, so you can pull that into the system. Give it my authorization code.
Oh no, just live authorization code typing.
Got it, always. And so we come back to the attack surface Hawkeye discovery, and what we're going to see now is that it's going through all of my repos. A lot of them should show up pretty soon under this page, under the all repositories section. And so we've already got the full list. That looks like my full list of repositories. A lot of these are APIs, and a couple of them are not. And so now what it's doing is going through, trying to discover, based on file names, essentially, if I understand this correctly, which ones of these are actually testable APIs or web applications of any kind.
I believe what you meant, April, was based on StackHawk magic. File names is part of it, but there's a lot of magic and formula that goes into what we're doing here.
Yes, magic is important. It exists in today's world. So let's see. Yep, already. So not even 15 minutes. We've discovered all of the APIs in all of our repos. You can see that there's a couple that still were not marked as part of the attack surface. And that's because these really are not APIs. These are not testable applications. So all of the testable applications are marked with this purple sparkle, indicating that the magic has been applied and detected. They have automatically been added to the attack surface, but from here we could remove them. In the attack surface, of course, we can see all of this, including information about the frameworks. Now, this instantly gives, especially AppSec engineers or teams who are starting to set up a testing program or want to get started with StackHawk. These are the applications they need to go find and get under test. We found them in the source code, of course, and we can give you an idea as well as some of the latest commit activity and 30-day activity, just an indication of how active these applications are. You can also create applications from here. So I can just start by creating one. And now that I've got this set up in StackHawk as an application, it's been attached to the attack surface, and it's regarded as covered. But we don't have a configuration set up yet. We can start to go through that. We'll hit configure application, and we walk through the application configuration flow. Since this is brand new and the system has detected that I haven't done any scanning at all yet, it'll invite me to get the scanner installed locally and start to initialize it. I'm just going to pass through that and do a little dummy setup here.
Hey, April, can we jump back to the discovery screen real quick?
Of course.
Attack surface screen. So I think there's a couple really important things to understand about the screen that maybe aren't initially apparent. So first is, of how many of these repositories are there testable APIs and applications, right? So I think the repository count here was 10 or something.
Mm-hmm.
Yeah. And 8 of them are testable applications. So that's the very first part of like, how big is this problem? And then the next part that's in here that's interesting is you can see some of these repositories are already popping out as GraphQL APIs. Now, that's obvious in the name of the repository, maybe, but also our detection engine has said, hey, there's GraphQL inside of this engine. Now, as we continue to roll this feature out, the StackHawk platform is going to get smarter about helping you get these under test. Like if we already know it's GraphQL, we'll stub out some of the configuration for GraphQL testing. But today, it helps you understand what kinds of frameworks are out there. And maybe the question someone will have is, how many frameworks does it detect? And the answer to that is infinite frameworks. I don't know. We haven't run into a framework detection that didn't work. I think we have the over 1,800 frameworks detected so far. The next thing that's important is we're starting to help you do prioritization. What do we think you should get under test first? Now, usually one of the key parts of that is commit activity in the last 30 days. So you want to see when a repository is like bubbling its way up on its way to either super active development today, or even when a new repository gets made and commits start happening and then frameworks start showing up, you want to know about that before it gets deployed. And that's another thing that this feature helps security teams understand. So we send out alerts to say, hey, there's a new repository we discovered and it's got API in it, and it's testable. So connect with the development team. So I don't think yours has it, but we can show you the name of developers that are connecting or committing to this repository to help you connect to, hey, April, I see you started a new repository and my tool is telling me it's an HTTP application. Can you help me, or can I help you get it under test with StackHawk while we're developing it, so we can make sure that when we put it out in production, it's really good. That was one of the questions somebody asked was, how does the tool prioritize which APIs or applications should undergo security testing? And that's part of it. A little bit of like, when's the last commit? How active is committing? All those good things. Now you could take the opposite end of that and go, where are my zombie APIs that haven't been committed to forever and aren't under test? Maybe I want to test those as well. So that's the other end of kind of the spectrum And in between is like, how do you want to prioritize what applications and APIs to test? We always advocate for setting up process for the kind of normalized bell curve, 80% of the normal things that usually happen, so that they continue to be tested over and over. So you can spend time working on those second deviation outliers within your organization.
Scott, you
There-
mentioned, oh, I'm sorry.
No, I thought there was another question in here somewhere, and then it disappeared.
It did.
I marked that as we had answered. It was Lynn James asked that question. It was a great question. I think you answered it.
Okay, great.
You mentioned, Scott, that we send out notifications when there are new APIs detected. And I know I work with a lot of customers and prospects who are interested in automating around, repo creation. So a lot of times they are using infrastructure as code, maybe Terraform. And as developers create new applications, they, stub out a repo, and maybe they could also create a new application in StackHawk. And it would be really interesting if they could tap into our API. We've got a full featured API. And so we've had requests for sure to surface some of this information in our API as well. And I know that we've been talking about it internally. So that's also something that could, come if there's enough customer demand.
All right. Anything else you wanted to show, April?
No, I don't think so. I can just pop over to sort of a fully baked implementation over here, which is a different organization with the same set of repos, but we've got these actually have been fleshed out, and a couple of them have been configured as applications, and we've got some commit activity. But no, that was essentially all I wanted to show. Thank you.
All right, very good.
I think the really cool thing is we did it live on the webinar here. Like, that was a real flow. Like,
Yeah.
it's super easy, super quick, and can help you understand, and free, how large your application API security problem is based on that source code, which is kind of the only place that gets updated constantly as far as documentation goes, right? So like, if you have a Confluence page or some kind of wiki or something that you expect developers to update, like, for sure that's going to get missed. Source code is the source of truth here. There was the other question. Does StackHawk learn anything additional from the repo besides the endpoints themselves? So today, no. In the future, yes. So as we continue to improve this feature, it's going to get better and better. And the amount of stuff that we're going to be able to do is super exciting, super wide breadth. But our whole goal is to help you get things under test faster. So you can just imagine what that would look like for StackHawk over time. How do I help you configure? How do I help you understand where an application may be deployed? How do I help you understand what is a REST API and doesn't have an open API spec, so that you can help development teams like get annotations into code, or have Copilot get annotations into code, so that you can automatically create an open API spec for REST API. GraphQL and gRPC are a little different since they do self-documentation, which is great. But as the feature continues to get developed and used and more mature, it's just going to make the whole StackHawk experience much, much better.
Yeah, we definitely have really big plans, I think, as Scott is laying out. I would say today, just to make sure I point out what April just showed, we'll show you, so for every code repository, we show you whether or not we think there's an application inside of it. We also give you information about what languages and frameworks are in that code repository. And then we tell you how many commits have been to that repository over the last 30 days. This is all part of that prioritization that Scott and April were just walking through. And then lastly, the people that are contributing to that code repository. So we give you a little bit more information, but as Scott is mentioning, we have much bigger desires to add. So I hope that helps. Couple of last slides here. I think we have gotten some great customer quotes on this feature already. I think my favorite one is, and we didn't put it on here, but we'll just talk about it. We talked to a customer who said that they spent a year when they first got started at a company collecting the information that API discovery shows them in 15 minutes. So we took 1 year's worth of work and reproduced it in 15 minutes. I thought that was just outstanding. There's a lot of good quotations here from other companies that we're working with, talking about the overall speed of the scan. You know, we like customers to be scanning in less than 15 minutes. Talking about the design of StackHawk. You know, people mention that StackHawk really feels more like it's a developer tool. It has really nice design, nice UI features, things like that. And we work with a couple hundred customers. This is a selection of a few of them. I think we have more on our website. And so just want to kind of collect our thoughts on all of this. What we really talked about today was, you know, why is this suddenly a problem right now? And why have APIs sprawled to the point where it is important that we start to understand our API attack surface? And with that in mind, why is it so difficult to find them, to find the APIs? And then finally, we did a nice demo of the StackHawk's solution to this problem with our API discovery feature. And we hope you enjoyed it. So now we're going to give away a gift certificate. Am I going to say who it is, or are we going to email them?
We're gonna
hang-
email. Oh, go ahead, Scott.
Hang on real quick.
Hey.
Yeah.
Couple of things. First of all, we didn't add it in the end here, but StackHawk API discovery is free. If you're interested in how this works or what it looks like for your organization, and you have GitHub or Azure DevOps today, Bitbucket's coming. I think Dan said Bitbucket is coming next week, I believe is what he said. But
Very soon, imminently.
If you're interested in what it looks like for your code repositories, please connect. Please jump in there. Connect your repository. We'll do the discovery. We'll give you the information. It doesn't cost you anything. You can download that PDF or print it out and take it to your boss and be like, hey, our problem is a lot bigger than we thought it was. Or maybe it's exactly what we thought it was. And then secondly, if you have any questions about what we're doing here, why it's important, how it might apply to you, please drop something into the chat or into the Q&A. We'll be happy to answer them while we go through the logistics for the end of the webinar and all of the delicious foods.
All right. So we will get you an email. If you made it to the end of this, you'll get an email with or one of you will get an email with your Grubhub gift certificate. And we really appreciate you all spending an hour of your time with us.
Thanks, everyone. And thanks to our speakers. And we'll be in touch soon. Bye.